Hello, this is Timberlake Basic Chemistry, and we're in Chapter 8 on chemical reactions. And today we're looking at the reactions of organic compounds. Now, this is the only section that I would ever do in chemistry on organic chemistry. Organic chemistry usually is carbon, carbon and some normally nonmetals with hydrogen. So hydrogen and nonmetals along with carbon. So it's a molecular bond. It's sharing electrons, not stealing. But I wanted to mention combustion. I mentioned it to you yesterday in yesterday's class. Combustion is burning. Anytime that you have fire, that is a chemical reaction with oxygen. So I wanted to at least review it. So this is a very simple lecture. So combustion is always going to make the same products. No matter what you're burning, you will, if you burn it completely, fully burn it with no leftover pieces, so no cinders or no black logs that didn't burn, but if it's completely burned, you will always get two things. You'll get water vapor, okay, so gaseous water, and carbon dioxide. Okay, so if you were to burn something perfectly efficiently. Now, if I've ever burned in a fireplace or in a campfire, I get tons of ashes and soot and cinders. Those are non-burned pieces that still have energy in it that haven't been burned effectively. So a lot of time a fire has to do with, can the oxygen reach the parts of that material that's acting as fuel? So to burn it more efficiently usually means you grind something up. So a pellet stove, if you've ever seen a pellet stove, which is still wood, but it's tiny pieces of wood, is better able to burn than a log in a fireplace and more efficient in terms of getting more heat out of it and less soot, cinders, and ashes. Okay, so in this case, I've got methane gas, CH4, and it's burning in oxygen, and oxygen in the free state is always O2. Oxygen is very reactive, and it reacts with itself in the case of O2, and so oxygen in the air is O2, and it will always produce the same. It produces carbon dioxide, water, and heat. Okay, that's called a combustion reaction, and the water is in gas form because it's hot. So here is a case. This is propane gas. Propane C3H8 plus O2 yields the same, carbon dioxide and water and heat. So it really doesn't matter. Any kind of hydrocarbon plus O2 will yield CO2 plus H2O. That's called a combustion reaction. Okay, so let's balance this equation. All right, so I start with C5 on the left. So I want C5 on the right. Now let's do the hydrogens. I've got 12 hydrogens on the left, so I want 6 hydrogens on the right. Now how much oxygen do I have? I've got 2 times 5 is 10, plus 6 is 16, so this is 8 O2s. 2 times 8 is 16, so 1856. Alcohols will also burn. So not just hydrocarbons with carbon and hydrogen, but also an alcohol is normally an oxygen-hydrogen end to a hydrocarbon base. So you have, in this case, CH3 joined to CH2, so that we've got 2 CHs. This is ethane, okay? Now the OH is an alcohol, so this is ethanol. Ethanol is moonshine. That's typical drinking alcohol, so brandy or even wine. Of course, wine's got more water than alcohol in it, but anything that would be just pure drinking alcohol or cooking alcohol would be ethanol. It burns in O2. It burns in oxygen to form, you got it, CO2 and H2O. So hydrocarbons, carbon and hydrogen, burns to make carbon dioxide and water, and alcohols also burn to make carbon dioxide and water. And both of them release heat, and we'll talk about that in a further lesson. All right. Hydrogenation, this is a special case. In a reaction called hydrogenation, a hydrogen atom adds to each carbon of a double bond. So if you have a double bond, let me start on this side. Maybe I'll start here. Do you see this is butane, which means 4 carbons, and this has carbons hold hands with 4 things. I'm going to redraw this. So this hydrogen can go down here, this hydrogen can go down here, and then these can go here. So carbons all hold hands with 4 things. That means it can hold hands with 1 carbon, 3 hydrogens on the end, 1 carbon and 3 hydrogens on the end, 2 carbons with 2 hydrogens in the end, in the middle, 2 carbons with 2 hydrogens in the middle. So if you have 4 carbons, and you have every single carbon holding either a carbon or a hydrogen, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would have CH10. All right. Let's look at the other side. I've got 4 carbons. This one's holding hands with 3 things. This one's holding hands with 3 things. This one is holding 1, 2, 3, 1, 2, 3, and only 1 hydrogen. Okay, so instead of holding 2 hydrogens on both sides, it's holding a double hand with a carbon. It's making a double bond with a carbon, and then holding a hydrogen. Okay, so this is called saturated and unsaturated. If you've ever heard of saturated fats, unsaturated means that it doesn't have as much hydrogen as it could have. Saturated means it has as much hydrogen as it could. So on this side, this is saturated because every single arm is either holding 1 carbon or a hydrogen. Okay, this is unsaturated on the left because instead of just holding 1 carbon's hand, it's double holding. It's holding 2 arms with a carbon, and so this is called unsaturated, right? So in a hydrogenation reaction, a hydrogen will come in. You'll end up holding hands with 2 hydrogens, and then that double bond will break, and you'll end up with a single bond. Okay, that's called hydrogenation. And usually a catalyst is used. All right, so if you have anything that has a double bond, you can a catalyst can break that double bond into a single bond, and then hydrogen is brought in. It takes out hydrogen in order to do that. You can take the hydrogen in different places. You can take the hydrogen out of air. You can take the hydrogen out of water. Okay. Most of the time when you think of something being saturated or unsaturated, we're talking about oils and fats. Okay, so for instance, shortening has so margarine is not saturated. It's saturated. Margarine, Crisco shortening, vegetable oils are unsaturated. So because that double bond has changed its properties, it makes it solid at room temperature. The fat that is liquid at room temperature is saturated. It's holding only hydrogens and carbons. Okay, so if you add hydrogenation to an oil, you can produce a kind of a weird fat. So Crisco, which is called a shortening, is a hydrogenated fat. Margarine, which I don't know if anybody uses margarine anymore, is kind of a liquid butter-like substance where hydrogenation has happened. It makes an oil essentially into a solid, so it resembles butter, but it doesn't taste like butter. So write an equation for the hydrogenation of, okay, so I've got 1, 2, 3, 4. So this is butene. 1-butene is the name of this reaction. So if I add hydrogen into it, okay, hydrogen gas plus CH what? 2, 3, 4, 5, 6, 7, 8, okay. H2 plus CH8 oh no, I'm sorry, it's C4. There's 4 of those. C4H8. It's going to come in. You're going to end up with C4H10. Okay? And it will saturate it. So unsaturated, remember oils are unsaturated. The solids are saturated with all the possible hydrogens that you could have. And that's what you got today. All right. Thank you.